Now we are ready to study the characteristic of a photodiode, and we will do the experiments with the photodiode both in the photovoltaic mode as well as the photoconducting mode. Essentially then, there are 4 experiments. In the first one, we will measure the responsivity of the photodiode in the photovoltaic mode, and then we will switch it on to the other side. We will make it to the photoconducting mode. There also we will measure the responsivity. Then we will introduce neutral density filters and see the linearity of the responsivity. Finally, we will remove the helium neon laser, which has got only one wavelength, and replace with the argon ion laser, where you can tune it. Therefore, we can measure the responsivity as a function of wavelength. So let us take a look at the experimental setup itself. I have deliberately switched off the chopper because the chopper is making a little bit of noise, so I don't want that noise to interfere with my talking. So I'll later on show you actually how it works. Here is the helium neon laser, and this of course is 5 milliwatt helium neon laser functioning in TM00 mode. Here's a chopper, and it has got a power supply with which you can vary the frequency of the chopper. And then here is the photodiode, and we have the power supply for that one. This power supply will allow us to use both in photovoltaic mode as well as in photoconductive mode. This is connected to the output of a oscilloscope. So in the first part of the experiment, what we will be doing is, first we will allow the beam to go through this chopper, adjust the chopper such that we get the pulses of exactly required height, and then measure the pulse output, the voltage. And then we have a power meter here, and which we'll put directly in the laser beam so that we can measure the power in watts. Therefore, the ratio of these two things gives us the responsivity. So, the experiment for all the 4 parts essentially is the same thing. So, in the first part, let us describe one more time, and then we'll switch on the chopper also. So, the laser beam with chopper chopped into a number of pulses and allowed it to fall on the photodiode, which is first in the photovoltaic mode. The output is connected to a oscilloscope. Incidentally, this experiment we are following exactly as it is given in the book. Therefore, we can follow step by step. And then we have here a neutral density filter. This again is one of the varieties of neutral density filter where the intensity can be increased or decreased according to our will by rotating this wheel. So therefore, we can measure the output intensity as a function of the transmission characteristics. Therefore, if we take it at different intensity levels, we can draw a graph between the intensity versus the responsivity, or the number of filters versus responsivity. And the same experiment is repeated again in the photoconducting mode. So we get 2 more experiments, and finally remove this one and put the argon ion laser. Now we will switch on the chopper, and we'll show you how the pulses will look like. Now the chopper is on. We can easily see that the light coming out of this is chopped by the chopper, and that's falling on the photodiode. We can see the pulses here. We can adjust the height of the pulse as well as the width of the pulse so that we can accurately measure. We want 1,000 pulses per second. That's what we want. We can adjust that by adjusting the timer on the oscilloscope, and therefore we can measure the voltage coming out of this photodetector. And then here is the direct measurement for the watt output power. We have a detector head here, so we will put it inside the beam before the chopper, such that it will measure directly the power output of the laser beam. So the ratio of these two things will simply give us the responsivity. Once we do that, what we'll simply do is we'll introduce the neutral density filters in the path of this one, and then we can actually arrange this one in such a way that the intensity is increased or reduced. You see, you can actually change the height of this one. Can you see that? So you can do that, and you can measure it for different neutral density intensities. You can perform the experiment, finding out the responsivity. In this particular setup, we have a facility by which you can simply change from photovoltaic mode to a photoconductive mode, and we essentially repeat the same experiment. After all this is done, all we are going to do is replace the helium neon laser with the argon laser. The advantage of the argon laser is, of course, we all know that we can tune the argon laser to give a different wavelength. For example, the 488, 516, and so on and so forth. We have a number of colors. So therefore, we can measure the responsivity of the photodiode as a function of wavelength. And we have a table given to you earlier, and we will fill up those tables. So we can perform 4 different experiments with the